And in the video, we did not get to number 5. Oh, hold on. Okay, so we are on problem 5, example 5. So if we look at this problem and we do the steps, is example 5 written as numerator over denominator? Is example 5 written in descending order? Example 5. The exponents are in correct order?
Yeah.
Yes, okay. Is it written in factored form? No. Okay, so let's factor it. Now, if we were to factor the top of example 5, what type of factoring is the top? It's a quadratic, and it's difference of squares, right? So we're going to have 2 sets of parentheses, one with a plus, one with a minus. Okay? And the perfect square is 16.
X plus 4, X
Uh-huh.
plus 4.
Yep, x plus 4, x minus 4. Okay? And then for the bottom, the type of factoring we have to remember is that if we have a negative in the front, we're going to factor out a negative.
-1.
Okay, so we're going to take a GCF of -1 out. And then what are the leftovers?
X minus 4.
X minus 4. Okay, so we've gotten through the first 3 steps. Step 4 is to reduce the common factors. So x minus 4 and x minus 4, we can divide those. The same thing divided by itself. Anyone remember what the same thing divided by itself is? It's 1. Okay, it's not 0, it's 1. Okay. Yeah, 0 divided by anything is 0, except for itself. 0 over 0 is undefined. You can ask Siri. Siri has a good answer for that. Yeah. Okay, and so then after we divide the things that are in common, then we write the simplified form of the final answer. And so over here we have an x plus 4 divided by a -1. Should we leave a -1 on the bottom of a fraction? No, that'd be weird, right? Yeah, it'd be weird. So is it possible...
X plus, or you put a -1 outside, or if you wanted to, you could do -x minus 4.
Yeah, perfect. So we could do negative on the outside. This is one answer that people would write. Or we could take each term and divide it by a -1. So -x minus 4. Both of those answers are good. And if you were doing a test or a quiz, both of those answers would get full credit. And if it was a multiple choice test or quiz, I could see both of those answers showing up, not at the same time, but I could see either one of those answers showing up in a multiple choice section. So, okay.
This one. Oh, the next one, sorry.
Ooh, the next one.
Yeah, the next, okay. So both of them are quadratics,
Uh-huh.
but the top is not in descending order, so
Yeah.
we're going to change that. It's going to be x squared minus 4x minus 5.
Okay, perfect. So it was already written as numerator over denominator, but it was not written in descending order. So we're fixing that. And then immediately we just go cancel those out. We're good.
Yeah.
Do we do that?
Yeah, because...
No, we don't do that.
No,
Because
one's
this kills puppies. This kills puppies.
if one was a negative...
Puppies. Okay, now we're talking.
Wait, if one was a negative and one was a positive, did you cancel it?
No. So and it's because we haven't factored. So when you factor, you're figuring out what things multiply together, and this is a division problem. So multiplication, things that multiply and things that divide, those are two operations that are opposites and they can cancel. But this right here, do you guys see how these are subtracted and those are subtracted? Division and subtraction don't cancel.
So you don't drop
Yeah.
those until you simplify a little bit.
Exactly. Yeah, and if you do it too early, then you kill puppies, and we don't want to kill puppies because that's. I mean, you can kill a sugar glider or an otter, and I guess people could justify it, but you kill a puppy, everyone's against you. You're a real murderer. You're cold-blooded. All right, so we did the first 2 steps: numerator over denominator, descending order. Now we got to do the factored form.
Shush. X plus 1 and then x minus 5.
Okay, so for the first one, we're multiplying to -5, we're adding to -4, and Holland noticed that the numbers would be -5 and +1. So x minus 5 and x plus 1. Have we figured out the numbers for the other one yet? Multiplies to -15, adds to -2.
5 and 3.
5 and 3. That adds to 8, you guys.
-5.
There we go. Okay. So x minus 5, x plus 3. Okay. So now we've written it in factored form.
Oh, you can drop the x minus 5 though, can't you?
Yeah, so x minus 5 divided by x minus 5 is 1, so those go away.
Then you just got x plus 1 over x plus 3.
X plus 1 over x plus 3. Cancel the x's, you get 1/3, right?
Yeah.
No, that kills a puppy!
No, why did you?
Why are you murdering puppies? Goodness great. No, Holland did.
Wait. Why didn't you keep your parentheses?
That's a great question. Because when you have the top of a fraction and the bottom of a fraction, you don't need something to put these in a group anymore because they're a group on the top.
Okay.
Yeah,
Okay, and then, well, we're done.
that's it, yeah.
Because then
So...
how can 1/3 equal that?
It can't, yeah. So we can't cancel anything else as tempting as we want to because we would kill a puppy, first of all, and that's just terrible. You're a terrible person if you kill puppies. But then because, now listen to this reason, because x plus 1 is addition,
Yes.
x plus 3 is addition, if you're trying to cancel with division, addition and division are not opposites. They do not cancel. It'd have to be a multiplication. So if you said x times 1 and x times 3, and you wanted to cancel the x's, then you
If
could.
you had a 3x and a 1x, then you just had a 1 over 3.
That would be fine, because you would be canceling multiplication and division. But if you have addition, and division, they don't cancel, you kill a puppy if you do that.
Technically, x minus 5 and then x plus 1, since they're right beside each other, parentheses level.
This is times. Multiply, divide. Ooh, I can cancel multiplication and division. I cannot cancel addition and division. See how that works? But it's hard to say that out loud, and it's a lot of words to say it. So we just say don't kill a puppy. So just don't kill a puppy.
Wait, so what's the difference between this one and the one we just did before?
See how this times this? That's multiplication. This is division. So I'm canceling multiplication and division. Cancel. This is addition. X plus 1 divided by x plus 3. So addition and division do not cancel. And that's why I couldn't do it. But because this was x minus 5 times x plus 1, the times and the division is what made it so I could cancel. And that's why it was the whole chunk. So it was something times something, something divided by something. Yep. Okay. All right, so the final answer here is x plus 1 over x plus 3. Okay. Now, we got to go back because there was something in the notes you guys did not fill out.
Oh yeah, the word.
An excluded value. An excluded value is a value that makes the expression undefined. Did we all write that?
Yes.
An excluded value. An excluded value is a value that makes the expression undefined. Rational functions are undefined when the denominator...
Wait, shush. 0.
0. When the denominator equals 0. Because you can't divide by 0.
No, it just equals 0.
Okay, so let's take our calculators. We're going to make sure
I hate the calculator.
that this makes sense. I'm going to show you guys where the excluded values are, but I'm also going to show you how to find them, okay? So The excluded value always has to happen before you simplify. Did everyone hear me?
Yes.
The excluded value happens before you simplify. Okay? So I'm going to type this in, 18x to the third over 24x to the second. Okay? So I'm typing this in.
Wait, how did you do the division?
Alpha y equals. First one. It's okay, I'll keep repeating it. Everyone got this typed in? Okay. Now, what I want you to do is, we don't even care what this looks like. We're going to hit second graph. And the excluded value is the x value where you get an error message.
So 0 is excluded.
0 is the excluded value. X cannot equal 0. Okay? This is the excluded value. X cannot equal 0.
When are we going to learn this stuff about log? Because we got a lot of questions.
I think it's our next unit.
Yeah, let's do log.
You'll learn next unit. Yeah. We gotta do this stuff before it gets, I want to make sure you don't have too much homework tonight. We have, they're all kind of, this unit is very repetitive. Okay, let's do the next one. I'm going to go back to y equals. No. Okay. Let's delete this. Okay, the next one. 7x, x minus 1. Yes.
3x.
But we did it to example 1 on the video.
Yeah, but we're proving that the excluded value is x.
Okay. We have two. Okay. The excluded value here. X cannot equal 0. X cannot equal 2.
So this means that if we got, so it means that if 0, we got 0 or 2 anywhere. Where does it mean if we got 0? Like, oh, like for the x value. Then they would.
You'll see. There's a pattern. Okay.
But
No, give it a second. You'll pick it up. Okay. So I'm just going to remind you of this one. Now, remember, the excluded value comes from the problem before you canceled anything, okay? Now, the next one, you can type it in like this, or you can type it in like a fraction. It doesn't matter, okay? So I'm just reminding you guys that we did have this, okay? So I'm going to go ahead and I'm going to type it in exactly the way that they wrote it. Okay. Oops, I missed a parenthesis. Make sure you don't miss any of your parentheses like I did. Okay. Look, oh, there's one of my errors. Oh, okay, there's my errors. Yeah. Before you leave though, come grab this.
is it time to leave?
No, she has to leave for PCC. Okay. Everyone write this down? Okay. Let's flip to the next page. We're going to once we get there, you'll be able to see it. We're just going to do all of them and then we're going to come back to it, okay? Once we get to all of them, you'll be able to see. Okay. Now this one was okay. Now let's type this one in. Oh, okay. Look at the errors on this one.
Negative. Oh, wait.
Negative 1 and 0.
0.
Okay.
Wait a minute.
On the back now.
One of the answers is always one of the numbers that we get. It's like negative root of it.
Okay. Okay, let's do number 5. I don't see any errors up there. Oh, there's the error. Okay. Okay. I think once we get done with all of them, you guys will be able to see it.
How are you so fast at typing on the calculator?
Because I've been doing it for a very long time. Oh, there's 1. 5. 5 and negative 3. Opposite of what? Okay, so you guys look at all these excluded values and see if you can find what's in common.
It's always denominator. It's always the opposite.
It's the denominators.
Negative.
It's the opposite.
Opposite of
It doesn't mean necessarily negative. It's either negative or yeah. That's what I mean.
Okay, so this comes from, and it's before we cancel anything out.
Yeah, but it's an answer.
Okay. Can you guys see it?
Yeah, it's a denominator.
Okay, so do you see how it's the denominator? So it's before we cancel out. If you look at the factored form of the denominator, it's the opposite sign.
Yeah, it's if it was equal to 0, then it would be.
Yeah, because it's if it was equal to 0. Yeah. So if you were to plug in positive 5, 5 minus 5 is 0. That would zero out the denominator. Or like negative 3 plus 3, that's 0. That would zero out the denominator if you plugged it in. This one, 4 minus 4, if you were to plug that in, that would zero out the denominator. Okay. And you can't have 0 in the denominator because anything divided by 0,
That's why it does it.
that's why it gives you an error message.
You know, why does the other one? Why is there like other? So like, sometimes there's 2 of them for each.
Okay, so sometimes there's 2 of them because there's 2 x's. And then sometimes there's 1 because there's only 1
So it's
x.
whatever's on the left.
Okay, and then so this one had 2 because there was 1, 2. This one only had 1 because there was only 1. And then this one had 2 because there was 1, 2. Okay, so do we see where the excluded values come from? Yes? Okay. Do we see how there's more than 1 or if there's just 1?
Yeah.
Yeah?
But or there's 0.
Or, yeah, can somebody tell me a situation where you could maybe not have an excluded value at all?
If there's just if there's no all that cancels that.
If there's no x value. Not if it cancels, but if in the original problem there's no x. If it was just a number. Yeah, because remember, it's before they cancel out.
Yeah.
It's before they cancel out. It's not after they cancel out, it's before. So if you were doing a problem and it was just like x plus 2 on the top and then like 5 on the bottom, if there was no x on the bottom, you'd have no excluded
Wait, but
values.
how about like number 2?
Okay, number 2.
When you still have x's on the bottom, but then
You-
it's still, or example number 2.
Example number 2 would have excluded values
But how does that have an excluded value of 0 if there is x values?
because it's right here. This is the excluded value of 0. This is an excluded value of 2, excluded value of 0. So anytime it doesn't have something with like the parentheses, anytime it's kind of like a GCF. So this kind of feels like a GCF.
Because if you plug 0 in, you multiply.
Uh-huh.
it's gonna be 0.
Yeah.
And I can't.
Yep, exactly right. Okay, so let's, I'm going to go ahead and hand out the worksheet so we can practice some of these. All right. So somebody tell me, what number could we divide out on the top and the bottom? 10. I'm going to divide by 10 on the top and get 2. I'm going to divide by 10 on the bottom and get 3. And then if we have x to the 4th on the top and x to the 3rd on the bottom, how many x's can we take out of both? 3. We can take out 3 x's on the bottom and they're gone. We can take out 3 x's on the top and we get 1 left over. Okay, so our final answer is negative 3 on the bottom, okay, 2x on the top, 3 on the bottom, and we're done. So those ones are pretty simple because those are monomials. You're just reducing. Now number 7 and 8 are saying do the same thing, but also state the excluded values. Okay, so let's do number 8. So 27 and 72, what number comes out of both of those? 9. Okay, 27 divided by 9 is 3. 72 divided by 9 is 8. And we can take 1x out, so the one on the top is gone. Take 1x out on the bottom, we have 2. So 3 over 8x squared. Okay, now do you guys want to graph this and look at the table to find the excluded values, or do you think you can just tell me?
I think we can do it.
Okay, so x cannot equal 0, okay? And then if you ever want to verify it, just graph it and look at the table and see what gives you an error message. And then you'll know you got it right, okay? All right, let's look at I'm going to look at number 9, so I'm not doing all your problems for you. Can you guys see what would cancel out in number 9? What would cancel? In number 9, what would cancel? Okay, 6 and 6, x and x. Can I reduce the 4 and the 6? Wait. Can I reduce the 4 and the 6? No, because there's a plus in between. Do we see the difference between this and 2 and 3 and 4 and 6? Do we see the difference between this and the ones above? The ones above were written right next to each other, so they were all being multiplied by the thing that they were next to. This is an addition problem, and addition cannot reduce like that. Okay? So since these factors, since 3x plus 4 and 5x plus 6, since those two parentheses are different, they cannot be touched. They can only cancel or reduce or anything if they're identical. So that's the final answer is 3x plus 4 over 5x plus 6. You're all done. Completely done. That's it. That's that whole answer.
And then our excluded values would be...
You don't have to find it. But if you did, you would say x cannot equal 0. X cannot equal negative 6 fifths.
So when you're finding the excluded values, you look at the original of that problem before you
Before you cancel out, and you look at the denominators in factored form. Yeah. Okay. Let's look at number 14, because this one's you do have to do, and you do have to state the excluded values. So what do you guys see that can cancel on number 14? 7s and the A's. Okay. What about the parentheses? Do those reduce at all? Nope, they're not identical, so we can't do anything without killing a puppy, and we don't want to do that. Did somebody say, what if I do?
Yes.
Taylor. All right, so we have 2 A values, which means we have 2 excluded values. So, or negative 4, negative 4, negative 4,
Why do you keep saying -4?
negative 4,
Hey.
negative 4, negative 4 over 5. This one happened to be a fraction because there was a number in front of A. So it's negative 4 fifths.
Oh yeah, because like if you were doing 0.
Very good. Okay. All right. Ooh. And then we get to the back side, and we're like, oh, thank goodness I wanted to practice my factoring. That's the sound of happiness. Truly. Truly, that's the sound of happiness. Okay, so you guys have like 15 minutes or so, and we're just doing the evens for full credit. So I think you guys can probably finish this in 15 minutes. Okay. Answer key is on the wall if you need to check your answers. It's extra if you do even, or it's extra if you do odds, yes.